Welcome back everyone to episode 3. So in episode 2 we had looked at sketching and defining sketches, and in episode 1 we had looked at the user interface and how to set up the program, etc. So today I'm going to finish that fully defined sketch and we're going to look further into the physical features to make 3D models. So let's start off. I'm going back, starting a new part. So I have my part and my OK. And my part opens for me. Give it a few seconds to open. When my part opens, you can see I'm back to part 1. As we had discussed last time, every time a new part is opened on the computer or a new file is opened, it goes 1, 2, 3, 4, 5. The reason it resets back to part 1 again is because I have shut down my computer in between opening the next part. We have our front plane, our top plane, our right plane and our origin, and at this stage we should know how those 3 planes and that origin interacts. One thing I will say is that we can also add new planes as we desire. For the moment I have an exercise, and this is put up on screen here. If you want to just grab a screen grab of it, you can work away yourself putting this exercise together. It tells us a lot of information. Now, it tells us our unit system is mmgs, which is millimeter grams second. So that is our actual unit system that we can use. It tells us our decimal places is 2. So it needs to be to 2 decimal places accuracy. And we can see that here by the 37.5. It tells us that our part origin is arbitrary. So arbitrary in this term means that you can decide yourself where you want to have your origin. Now there is a rule of thumb for the origin. I would usually either pick a square corner or the center of a circle. Just makes it handier for an origin. We have a material of AISI 1020 steel. So we have to put in a material for it as well. We have a density. And we have all holes true unless otherwise shown. So, it tells us directly where those holes are gone the whole way through that model. So for the likes of this one and these ones. So the exercise then is model a component using these relations and dimensions. Now I have highlighted there that the sketch must be fully defined. There are lots of users out there that do not use fully defined sketches. If you do not use a fully defined sketch, you open your model to error. So you might go and change something small in a model which would have a larger knock-on effect because things weren't fully defined or fully restrained within your model. So I also have a few pinpointers here of relations to use. So we want to look at our coincident relation, our horizontal and a vertical. And we have some commands here to use as well. So we want to sketch on a face, we want to use a full round fillet, and we want to use a chamfer. So these are the kind of exercises that I do at the beginning of a CSWA course, just to get people kind of in the mode of how to interact with a component and how to build up that base infrastructure of that component. So there's lots of different ways to build this. The way that I show you in this course or show you on this video is only my interpretation of the way. You could draw this component 3 or 4 different ways. What decides if the component is drawn correctly or not is actually the amount of time that is used to draw that component. There is other things that you have to take into account when drawing these components, such as things like design intent. Otherwise, is it easy to modify or change the model? Manufacturing might have issues with trying to produce the component the way you're drawing it. There is lots of different characteristics that decide how something is drawn. The best way to learn the software is to know all the different ways of drawing that one component. And then you can add the characteristics that is required to it. The way we're going to look at this, I'm going to draw a block of material. I am then going to cut out the different pieces, as in holes and slots out of that block of material. And to finish then, I'm going to use a chamfer command to chamfer all the edges on that material. Let's have a go. Take a screen snap, follow along, and this is the first exercise we do. I have exercise 33. Obviously on courses there's lots of exercises because I provide feedback etc. for learners. How do I know what plane I'm going to draw on? Now there is a perfect question that I get asked many times. How do I know what plane my drawing starts on? The best answer I can provide for that is usually draw on the plane that has the most information to create the model. That is in general. There's often times that you might have to pick the plane according to another parameter or with another restriction. This time I am going to start on my front plane. This is the image of what I'm going to draw. If I look at that image, I can say this here looking this direction is my front. This looking down is my top, while this looking in this direction is my right. If I go back to my software and set up my planes, I'm going to show my plane by right clicking and press my eyeball, eyeball, eyeball. And if I press my spacebar and then use my isometric view, or Control 7 does the same, you can see there is my front plane, there is my top plane, and this side here is my right plane. So if I was to put my image in that would mean that that's the front, that's the top, and that's the right. The best way of understanding and getting used to this is just practice. Keep drawing objects and deciding yourself, okay, this is my front, this is my top, this is my right. And then that will eventually just become a second nature to you when you're starting to draw objects. Okay, so we have identified something. We have identified that we're going to start with either our top or our front plane. Well, I'm going to just pick my front plane. Doesn't particularly make a difference. The information I have on my front plane, if I look at my drawing here, is that this is the top view looking down. We can see that because of the position of the hole cuts, etc. So that's looking down. We then have a a front view looking this direction, and we can see that with our holes the way they're laid out as well. And then this final one is looking in that direction. The only thing that I'm concerned about at the moment is this view here, this front view. I'm going to put that out of the way for the moment and also put this one out of the way for the moment. It's just the front view is all I require. Let's start off. Where would be a good place for the origin of this part? Now, it does say arbitrary, so we can do it wherever we want. I would kind of think maybe there, well, it's the center of a circle. Could say here because it's the center of a circular slot. There's a good few places that you can do it, and it's up to your own choosing. For me, for some reason, I'm going to say it's this point here. So that cross is where I am saying my origin point is. So I need to find that point on my actual software. I jump back to my software. I know it's the front plane I want. So I'm going to hide this and I'm going to hide this. So I hid my top and my right. I'm saying my front plane and I'm going to say sketch. What shape do we have here? On our drawing, we have a slot shape. Well, that's the first thing I'm going to make, is that slot shape. Before we even start drawing, we want to make sure our units is mmgs. So millimeter units. If I drop down here, mmgs. Perfect. I know that I'm the correct unit style. If not, I could go for CGS or MKS, etc. But as long as I have mmgs, which we pretty much do most of our drawing on, I know that I'm good. Next thing I want to do, I want to start a sketch on my front plane. Right click, sketch. And there we are. We're starting. I want to put in a slot. Well, what information do I have? I know I want 2 points on the slot. Otherwise, the front of the slot on this one, and also, front of the slot on this one, and also this one here. So those are my 2 dots that I need. Well, if I jump back into my software again, I can go and use my straight slot. Click on the straight slot, make sure it's on this one, click one, move your line out, click another, and drag the box out. Now, my mouse is free dragging there. I'm not clicking down or holding any buttons. Click. It has add dimensions here. If that is unclicked, it won't put in the dimensions first. I'm going to unclick that. I usually have it unclicked. Oh wait, I had already added the measurements into it. Well, that's not really the measurements that I want in the place that I want. So for me to delete those measurements, if I click on the measurement and press the delete key, click on the measurement and press the delete key. And that is those measurements deleted. Let's have a look at what measurements we're given with our drawing. Is we have a radius of 0.5 or 7.5. We have a distance of 10. So it's not a very big slot, but it still needs to be represented accurately. So we have a distance of 10 with a radius of 7.5. Well, the first one I'm going to do is put in that distance of 10. Smart dimension, click, drop down, and you see the point to the point, drop that guy down 10. And now we have our distance of 10. Next thing we need to do is a radius of 7.5. Well, still on my smart dimension command, if I just click the radius, it comes up for me, 7.5. If you look down here, fully defined. So, we are making a fully defined sketch as we go. There's lots of people out there that will use the software, draw what they want, and then fully define it. If you're used to using the software, you will fully define as you travel through your drawing. It's not a step at the end of the model, it's those individual steps throughout the model. Let's have a look at what else is on this image. We have this guy in place now. As far as I can see, can't we put a radius of an arc around this guy running to that point? And that would give us a radius of 15. And then we can assume that this is a straight line and this is a straight line. So they are horizontal lines. So let's have a look at that. If I use my center arc, click, 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 and just swing. There we are. See the way it comes up with the half line, meaning that we've cut our half circle arc. Click. And you can press your escape to go back out of that. Later on, we'll see how we can use tools without having to press escape. We can change from one command to another. I'm taking my straight line and I'm drawing off horizontal. Go and close off my line, take my line again. Horizontal. Perfect. We had said that this curve is a 15. Well, let's put in a 15. Okay, we have a radius of 15. What else is on our drawing? If we go back to our drawing again, you can see we have our radius of 15. So I am after putting this much together. That inner piece and that curve. Our two straight lines out here, well, I know from the point of the slot there out to the end point here is 85. So we can easily do that 85. Give me my smart dimension and I'm going to put 85. And that brings me out to that point. Well, I know it's 85 in the top and it's going to be 85 in the bottom. So I want the two of these to run equal. Well, can I put in another measurement of 85 on the bottom? Of course I can. But now I have 85 on the top and 85 on the bottom. You can imagine if there was 3 or 4 of these, well, then you'll have more 85s and 85s. The drawing becomes more complicated and harder to read. So I'm going to take away my lower one again. But still that means that this line can move. I don't want that line to move. I want that line to be the same as that one. I'm going to hold my shift with my left shift. Hold that guy down, click, and click. if I click on my two lines while I was holding my shift key, you can see I get my properties box. And the properties box is telling me line 4 and line 5 can have a property. Now, a property or relation, we'll say a relation. So what is this relation? Horizontal. This one's horizontal. This one is tangent, and this one is tangent. Well, I'm going to add another relation, and it's kind of highlighted equal relation to me in bold. So it's kind of telling me, well, it should be equal relation you're probably looking for. If I say equal relation, it's going to throw up some message there, but it's going to give me this line and this line are now equal. If I click OK, you can see my sketch is fully defined once again. Why am I using relations to define sketches rather than measurements? Measurements, or too many measurements, can make it very hard to modify or correct models. Relations are less computer power and are easier to modify and correct models. Let's see what else we need to do. So now we have our two lines out at 85. And as you can see, I am just building this the whole way across. I need to put in a slot here. Well, let's see, what kind of slot have we got? We know that it's 15 between the inner jaw and the inner jaw. Okay, so if it's 15 between there and there, what kind of radius does that give us? That gives us a 7.5 radius. So we actually know what radii is here because we know the distance. Our 45 then from the outside edge to the inside curve. Well, that 45 tells us, okay, if we come in there, put in our curve, we should be the same here. Let's have a run. I'm going to put a line across here now, and I'm going to bring a curve and cut it out to suit. As you can see, we have a bit of a construction line here. Well, I'm going to add some more construction lines. Taking my center line here. Remember, for the purpose of these tutorials, we're using the center line and construction line as being the same thing. And I'm going to click on my origin. And when I bring out my line, if I'm using just the normal horizontal line, you can see that it'll come up with that yellow horizontal. Now, if I need to lock in this line and I click, that yellow horizontal will turn to a green horizontal. Otherwise, it's locked in place. If I click now, it's going to give me a yellow horizontal and a white vertical. What's the difference there? Well, the yellow horizontal is going to lock it in as being a horizontal line. White vertical is only guiding me to say that it's the same length or ends in the same place as those two 85s. So I'm going to click. If I use my escape key, you can see it's now black line. You can see it's a blue end though. So the line can move up and down. Doesn't lock into anything. Well, why isn't my sketch underdefined? My sketch isn't underdefined because remember, the model or the software doesn't take blue or undefined construction line as part of the model. So it doesn't matter about construction lines being underdefined, or usually it doesn't matter. It only matters about the heavy dark outliners. I'm going to take my full solid line again. No, I'm not actually. I'm going to take my arc. And on my arc, I'm just going to swing an arc. Very same as I've done before. I'm going to swing half an arc. But as you can see, it's gone to the wrong side on me. I need my arc to be on the other edge. If I travel back up, is it going to do it again? Sometimes that can be a little bit tricky to get that to travel the right direction. But if you push it back and forward a few times, it usually runs right first. Going to use my line again. Come over, click, and up. Over, click, and down. And pretty much that's what we're going with. In our drawing, you can see that we had said from the top to the bottom is 15. So I'm going to put in a distance of 15 from those two edges. That's this edge and this edge. So let's get in 15 there. Using my smart dimensions, 15. And there you are, merges back to 15. So that gives me the radius here as well. If I click the radius here and click, oh wait, something is going to happen. Make dimension driven. Well, we don't want to make the dimension driven. What is happening here is that the computer is saying, wait, you're already after telling me it's 15. Why are you now telling me, well, the radius is 7.5? I know that 7.5 and 7.5 make 15. So stop telling me the same measurement twice unless you have a reason. We'll go into make driven dimension or dimensions driven at a later stage, but that is one thing that catches a lot of people. The computer has enough information, it doesn't require more. Just as a quick explanation of what make this dimension driven and leave this dimension driving is if you wanted to take an overall length of a line and you wanted to divide that line into 3 sections and you wanted each section to be a certain distance except the last section of that line, can make the dimension driving would be like a flexible ruler. It'll tell you how big and small that dimension gets if you change the length of the overall dimension. So we'll have a look at it later on. It's a little bit harder to explain. I might even make a separate video, a short video on it. So I'm going to click cancel because we're not interested in that. But now we have another issue. We've told it that it's 15 that way, but see the way it's blue? So it can actually travel back and forward. That's not what we're wanting. We need to lock this guy in. Let's see what we can lock him in with. We have a measurement, and we do. We have a measurement of 45. So that 45 brings me to this point. Okay, fair enough. Take my smart dimension. I'm going to click my line, 45. Is that correct? If I drop back to my image again. Oh, wait there. The 45 is the furthest point on the arc. Whereas my line, it's just a straight line that I've measured. If you were using the software to draw things, you just have to be a little bit technically aware of what you're drawing. You know, otherwise, is something a radius or is something a diameter? Is the measurement taken from the short side, the long side, or the center of a line? In this case, say we're taking it from the center of the line to the center of the line, when we should be taking it from the outside of the radius to the start of the line. So there is little bits and pieces there that you just have to keep an eye on. So I'm going to take off my 45, press delete, and then I'm going to go back again. I'm going to press my line again. It's still bringing me to that point. Okay, I'm going to take that off by pressing escape. I'm going to click my arc this time and click this. It's still bringing me to 45. That is not the point I want. I need it over here. Press my escape again. The secret is to hold down your shift key. So if I held down my shift key, click my line, click this line, now you can see it's saying it's 52.5. We want to change that to 45. And there we are now set at 45. Our sketch is fully defined. You can see that I have all my values on for my relations, and you can see the amount of relations that has happened here. Well, you could imagine if those relations weren't there, the amount of dimensions that would have to be there instead. When we're fully defining our sketches, we have a rule of thumb. And the rule of thumb is first use relations. Second, add degrees or angles. Third, add dimensions. Starting usually with the largest, working to the smallest. Well, that is the first sketch I have on my front plane completed. Close my sketch by just clicking my plus there or my green tick, and then I can actually close my sketch here if I wanted as well by clicking that. And there's my sketch. Now I'm going to also hide my front plane, and I'm going to press my space bar and look at my isometric. And you can see that is the sketch as it sits on our front plane. Does it match our picture? Since it's a 2D sketch, it does actually match our picture. Say if I had done something wrong and I wanted to rechange my sketch. I can sketch number 2 over here, right click that guy, and you can see I have edit sketch. I also have edit sketch plane, and I have configure feature. So anything with a pencil has edit. If I wanted to create a new sketch on my front plane, I can just click my front plane, right click, sketch. If I wanted to edit a feature or a sketch, I can click, right click, and then click edit sketch. So you're looking for the pencil if you want to edit. The next thing we want to do is start adding some material. I need a thickness of material here now. Okay, I have a 30 millimeters. So I know that this full piece needs to be 30 millimeters wide. So this is looking down from the top. We get our 30 millimeter thick. So I'm going to go extrude. I'm going to click my object, or click the outline of my object. And you can see, oh wait there. It's not giving me that center hole. What's the story there? I need to be able to select what I want to add material to. And using our selected contours here is where you can do that. If I right click and click delete, now you see it doesn't select any contour, it just uses its default selection. If I click on the area that I want to produce the material, you can see it says sketch to region. So that it says it's going to add material here. And that's what we want. How much material do I want to add? I want to add 30 millimeters of material. The default is always 10. We can add 30. So simply add in 30. Instead of pressing my enter or using my tick here, I want to update my preview and my preview only. If I press my tab key, you can see it updates the preview. It doesn't say that I have confirmed the command, it's just updating its preview. Have other buttons here. We'll look at the from here later on. But if we look at the direction, I have this button, reverse direction. So you can imagine this is coming one way and I'm going to send it out another way. If I click my reverse direction, it sends it the opposite way. So if I click it again, it sends it forward. I have a list of different commands under here. If I drop it down, I have a thing called up to vertex. So I can push material up to a point. I can push it up to another surface that I've created on my model. Or I can say away from this surface a certain distance. If there was more than one body or one block of material in my model, I can go up to model or up to body. The one I'm interested in here is called midplane. A midplane puts the original plane or the original 2D sketch in the center of the material. So it just drops it in that center first. We also have a feature down here that's a draft. So if I wanted to make it thinner, so if I draft it out, you can see I can make it thinner on one side and bigger in the center. Or if I wanted to make it what's called a thin feature, well, we can explore the thin feature later on, but the thin feature would make it as in something that has a thin wall on either side. So I'm going to set that back to my isometric, and I'm going to take off my thin feature. Doesn't need. So with my 30 millimeters material, I'm going to click OK. And now we have created an object that is 30 millimeters thick. Let's have a look at our sketch again, as I want to start drawing my top and looking down. So I want to draw this as my next plane. Let's have a look. We know it's the top plane. We're looking down on it. If I travel over to my top plane, I right click and I click sketch, it moves the object to suit where I want to sketch. What do we need to do by looking down on top? Well, we need to cut this hole out. That's one thing. We also need to cut this slot out, which is a second. Now, I am looking for some areas on my model that I know where different things are. On my 15, diameter 15, I know that that is coming from that point there, that point there. Okay, go back, look at my model. Haven't really got a whole lot to go on there. There's not very much information there. Okay, let's have a look at the drawing again. Okay, we have something here. It's a 15. And we have a 37.5 to there. So that tells us we know the length that this is to the curve and the curve. Let's put that together. I'm going to take a center line again. And instead of starting at my origin, I'm going to travel over to the edge here. And you can see as I travel over to the edge, it gives me a yellow square. That yellow square just means I'm halfway from there to there. But because I drew it in the mid plane, it also will cross over my origin. So I'm just going to draw that construction line the whole way across and click. Use my escape key and you can see I have just a black construction line there. On my black construction line then, I am going to place a few measurements. I know that I'm 37.5 gives me the center of this point. So if I take my arc, swing an arc, like so. As I said, sometimes it's hard to get that to run back. And I'm going to travel out 37.5. So I'm going to come over here. And I'm going to drop down a bit and come back. That distance is 37.5. But it's 37.5 now to this point here. So we want to get 37.5 to the center of our circle, which in this form is actually just a straight line, 37.5. We know that it has to be 15 millimeters in width. So if I put in 15, you can see, oh wait, there's something has went wrong on us. We needed this line to be smooth. Okay, well that's not what we were anticipating. What does it mean if that line is not smooth? Well, you can see that we have a tangent arc relation here, but we've no tangent arc relation there. A tangent arc is when you roll a cylinder on a table. The arc line is exactly where the curve meets the flat. So we want to turn this one and put in a tangent arc as well to line it up. One of the main issues with underdefined sketches is the loss of a tangent arc. So if you have a tangent relation, that's usually what stops people defining, or what even causes errors within drawings is usually that tangent is missing. If I click, hold my shift and click, you can see my add relations come up. And the computer is even suggesting you want a tangent. So if I click my tangent, now we're fully defined and everything runs back black. Why did I put on an extra line in there? The reason I put that line in was because I want to be able to select this area to cut from my object. So you can imagine if this was open, it would have no envelope or boundary to cut. Let's have a look at what else is required from us. We need to make a circle of 15. That one might be hard. How are we going to do that? We've no measurement from this point to this point. We've no measurement on this one. We've no measurement on any of them. This is a curve. So we know if we curved off the top, we would then have a point that we could attach this. Let's have a look at how we're going to do this on this side. I want to be able to cut my circle out in the one maneuver. Like we have a feature that's extruding or putting material in. I want to be also able to cut it with using one feature of a cut. We need to put something that will tell us where that circle will sit. I can do this numerous ways. One way I can do it, I can make a circle. The circle needs to be the width of the object. So if I just click my circle, drag it out, and you can see once it touches the edge of my object, I get a white tangent relation. I can click, and there is my circle. But remember, this circle is for construction only. Click. So there is the circle sitting in that boundary. But because my relation was only white, it didn't stick. I need my relation to stick. If I click on my construction circle, hold my shift, and click on the edge of the model, see what it says? Add relation of tangent. And it's suggesting tangent to me. So if I click tangent, okay, wait, it's still non-underdefined. Why? So relations can react with sketch entities to sketch entities, but it can also react with sketch entities to solid geometry, otherwise parts of an existing model, such as this edge. I'm going to do the same for this one. I'm going to click, hold my shift, and I'm going to click this edge. Wait there, it's telling me tangent again. If I click tangent, you can see it moves up, and now it's black, meaning it's fully defined. Once I have it fully defined, I know that I can put my circle in the center. The circle, we had looked at the distance of the circle, and the circle is a diameter of 15. If I put in my 15, now I have two pieces that I need to take out. I have this section here and also the section of my circle. Now I can also draw off these angles and chop them off as well, if I wanted. There is other ways, like there's lots of different ways of using this software to complete any object. There is a much nicer way of just chopping the edges off a circle. I'm going to go features. And under my features, I'm looking for cut extrude or extruded cut. Now, this is the opposite of this. One is add material. This is taking away material. If I click while having my sketch open, remember the last time we closed our sketch and then we added our feature? Well, you don't have to close your sketch. You can add the feature to an open sketch. My sketch is open, and how do I know it's open? Because it's highlighted. It's not in gray. I also have my close sketch button here, also there. If I go to my extrude cut, you can see it selects the two areas of that sketch that I've done. It knows there's a boundary here. It knows there's a boundary on our circle. Over here, we have pretty much got the same type of options. So the cut extrude and the extrude are fairly close with the options that they give. My option here is I can go blind. I can go up or down, or blind hole, which is just a hole in either direction. I can set my size. I can also do my draft. I can say I want it to go the opposite direction, so I could cut down 30 millimeters and up 20 millimeters if I wanted. I can also do a thin feature, and I can also use my selected contours. Now, I don't have to use my selected contours this time, but if I want to do, I could just click and click. So I could select one contour, and even though the other one has the sketch, it won't extrude or cut extrude that. You can pick and choose which ones you want. Once again, I'm going to go to my direction here, and you can see we have now got true all, both. There's lots more options here, but I'm going to put it down to true all, both. And what it's going to do, it's going to cut up and it's going to cut down and take the material out from both sides. If I click, you can see we're starting to get our object together. Another few little bits and pieces. We have our object is fully defined. Over here, I have my feature of an extrude and I have my feature of a cut. If I drop, I have my sketch, and if I drop, I have my sketch. Both sketches are fully defined and everything is good. This means that it's a selected region or contour. Let's keep working with our drawing. So our drawing has this done, this done. Our chamfer we can put in at the end. There's no issue. But what I want to do is my round fillet. So you can see I have a fillet here that curves that surface, and I have one that curves that surface. As you can see in our end drawing, we only have one. So I need to make a full round here. There is a command called a fillet, and a fillet is taking the edge off of something. It's making a round face. If I click on my fillet, you can see I have objects here called constant size fillet, a vary fillet, face fillet, or a full round. So it's the full round we want to look at. To be honest, the main two that's used is the constant and the full round. So on my full round, I'm going to go with my first box here. I'm going to click the side. Click down on my second box, click the front and the front. And on my third box, click the other side. It's not going to run for me. Why? Because it actually has two faces. Just need one face. So I suppose we may do it twice then. As I said, there is other ways of doing this that would reduce features and time associated. If I go back, I have one selected for each and I click. And you can see it has rounded the face in that for me. Well, if I go again with my fillet, very same, 1, 2, 3, and there it's rounded again. Now I have a stack of 2 fillets. There is ways that I could have made that in one move. So this is like playing chess. You can make certain things happen in one move or 2 moves. Sometimes you can reduce the amount of moves to create the same object. Let's have a look at what else we're doing. We have our rounds put in next. And for our final piece, we want to create a 1 mil at 45. So just a 1 mil chamfer the whole way around. Let's do that. That's not a complicated one. Under our fillet here, if we click down, we have a chamfer command. If I click my chamfer command, I'm going to put in 1 millimeter where that 10 millimeters is. And I'm going to actually click a face. So if I click the face here, you can see it will put up a yellow preview of everywhere that is going to be filleted. And isn't that perfect? Wait there, I just want to go back and look at my image again. If you look at our image, we can see that this circle is not filleted. So be careful if you're putting in fillets or chamfers that you don't just click on a face and say, yes, it's done, because technically it is not correct. There's oftentimes you get away with using it. It's a very fast thing to do. Click and it'll select all the edges for you, but just make sure things like holes not requiring a chamfer or fillet don't get chamfered. So if I'm going back, I'm going to right click and I'm going to use my edit feature, and you can see the pencil is there. So the pencil is always to edit something. I'm going to click off my face. What else am I going to use? I'm going to use my edge instead. And if I click my edge, you can see it's traveling anyway and it moves the whole way around for me. Click an edge here and I'm going to click my edge here. And now you can see it travels the whole way around, leaves this circle and this circle, this circle and this circle, and the edges on that the slot free and they don't interfere with it. Few things left to do. We need to add a material. So we had talked about adding material before. Problem with adding material, I often tend to add material before I start modeling the object. Why? Because especially if you're doing questions, it's often something that is forgotten when you finish the question. Otherwise, if you have 10 questions to do within a time limit, you are doing the question and you're delighted. You think, oh, I have the model there, it's perfect. And you move on, you forget to add your material. So what I always ask people to do is read over the question at the end of doing the question. The same if you try to sit a CSWA exam or CSWP exam or the CSWPA exams, it's always the very same. There is a certain number of times people will forget to read over the question. They'll have done all the hard stuff and then they'll have forgotten to add their material. The material is quite easy to add, but I want to show why you need to add it. Okay, I'm going back. I'm going to weigh my object. My object says it's non-specified material. Otherwise, it has no material attached. If I go to my evaluate, my mass properties, you can still see it brings up my part and it tells me a mass property of 40.04 grams. Wait, I have no material selected. That should be 0 because I don't know what I'm weighing. The problem with the software, and that's why I think it should be 0, the problem with the software is that it has a default weight category there. And it gives you the weight of an object, even though your material is not selected. Often people, if they're doing an exam, will fly along, create their object, perfect. Look, oh yeah, there's the weight and off they go. If that's at 0, they go, oh, I forgot to add the material. So we're calling that 40.04. The material we want to add is a material called AISI 1020 steel. So we know that AISI 1020 steel has a density of 79 grams per millimeter cubed. If I go over to my material here, I right click. Yes, I have it here in my favorites, but I'm not interested in going through my favorites to get it. I want to go to edit material. And if I click edit material, you can see there's a lot of material here. Lots of different types of material, and you can add your own custom materials, etc. Up my top box, 1020. Okay, it's narrowed it down to a copper alloy. No, it's not the copper I want. I have an AISI 1020 here, and I have an AISI 1020 steel cold rolled. Okay, so you're saying, well, both of them are 1020s. What's the difference? If I click on one, you can see that its mass density is 7900 kilograms per meter cubed. Click on the other. Its mass density is 7870 kilograms per meter cubed. Now, we are talking about such a small quantity, it won't give you that much difference in weight or in mass. But we still want to be right. So that one would be 79 grams per millimeter cubed. Apply, closed, and there is our object. That might seem like an awful lot of steps for that object. The more practice you get at these kind of objects, the faster the object will become. I can draw that object with less steps and still achieve the same outcome. I'm going to show what size my piece is. My mass is 316.29 grams. If you are attempting this at home with your own software, do try and match that. Try and get it to the 316.29. The best thing about SOLIDWORKS, especially if you're given the grammage of or the weight or mass of an object, is that you can match that weight or mass when you're drawing at home. You'll know if your model is wrong, if it's the wrong weight or mass. Okay, that's the end of episode 3. So on episode 4, I'll bring up another exercise or two, and we look at pretty much covering more advanced issues that we can do with the software, as in add in things like revolves. We'll look more on some of the features here, and we'll look at some of the whole wizard information, etc. Thank you for joining me. Please like, subscribe, and leave me a comment. I'm always mad to hear people's feedback and how people got on with exercises, if there's any improvements I can do on these videos, etc. Just let me know, and it's always good to get some feedback. Thank you everyone. Till the next one. Cheers.